1, and then 2. We're slowly building up our triangle, and then 3. So you see we're building out a triangle here, and each time we are adding a number, there are triangle numbers, and you keep adding one more dot each time, and that sort of gives total sequence in the end. We have the product, which in normally actually sum and product, they'll come together. It's very easy to get those mixed up. The product of two numbers is you get it by multiplying them, the sum by adding. And so just making sure, because quite often, rather than 42 add 12, they will say, give me the product of those two numbers, give me the sum of those two numbers, and be able to know which is vital. One that's not on here and is less common is quotient, which is divide. And I've not yet seen that one in the exam, which is why we don't put it on there, but that just goes the opposite way. As product is divide, quotient is divide. So I haven't seen that one yet, so fingers crossed. And really just to highlight that our number vocabulary is so important because it can limit the access to questions. So again, many students will know how to multiply two numbers, but if the question is, give me the product of 3 and 4, potentially a very simple question, but the student doesn't know that key vocabulary, they can't access the question, which is why it's just so vital to make sure those numbers, and I would say sort of are equally as important as our verbal reasoning questions, where again, lacking the knowledge of a question can just prevent you from being able to access the marks at all.
Thanks, Luke. One of the things I would just add to you, maybe to just give the parents a bit of a concrete example from a few years ago. We've always known that, learning maths vocabulary is important. And certainly when we've taught averages, we've always taught the mode, the median, the mean, and sort of connected to that, the range. A few years ago, one student came out of the test and said to his mother, what does modal mean? What's the modal number? Now, obviously, modal number is the most common, like mode, but it wasn't something we'd actually taught the students. We'd often talked about mode, but not the modal. So we learned from this, and certainly when we do teach averages, then we do mention that it could also be they ask you for the modal number, and that's the kind of thing that we do need to be conscious of. That maths vocabulary is quite broad, and it is important we cover off those different terms. As I said earlier, we will send out a glossary next Tuesday to everyone. So again, please do use it with your child. It may well be they know all of the words, but if there are words they're unsure about, then those are the ones to concentrate on.
Absolutely right. And here we just have a couple of sort of questions. Again, you're more than welcome to have a quick go just to see where really accessing the answers you will rely on this key terminology. And so again, perhaps just 1 minute just to quickly whiz through, and I'll steal the timer from before. Just have a go, because again, it just shows how, without access to those key definitions that we've now learned, you would not be able to access the following questions. So what are the 3 square numbers? What is the median? The 5th cube number? Again, it's not necessarily that it's difficult maths, but accessing it without the vocabulary is simply impossible. Right, so let's very quickly just whiz through these. Hopefully I can do them. So here, the square numbers, the numbers it times by themselves. So we have 1 times 1 is 1. I believe we have 3 times 3 is 9, and 4 times 4, which is 16. Off the top of my head, I believe those give us a total of 26. Particular one that catches students out is actually this one. 1 times 1 is 1. Also for your cube numbers, 1 times 1 times 1 is 1. And so remembering that is the first of the both square and cube sequences is really important. The 5th cube number, I'm going to jump to 3 because that's easier, is 5 times 5, so that's going to be 125. And then we have to put a bit of effort now into number 2 off the top of my head. So the prime factors of 21. No, list the prime factors are really important. So that is going to be 1 and 21. We then have 3 and 7. I think we're running out of those. So in this case, my list is in order. So the median of these numbers is the middle. Now, some of these are slightly easier than others. A really solid method, and just knowing this is, again, one of those little trips of trade. If you're going to find the middle of two numbers, adding them together and dividing by 2, in this case, 3 plus 7 over 2 gives us 10 over 2, which is 5. Now, again, you can count up 3, 4, 5, 7, 6, 5. Meeting in the middle is fine. But if, for example, I asked you for the middle of 27 and 42, that's a method that can actually save you a fair bit of time. So I believe in this case, the middle is 5, the median being the middle. Again, very easy. If you were to just write 1, 7, 3, 21, or in a different order, you get a very different answer. So I think these are my answers. I'll just give you a moment to ask any questions, check my working, and make sure we're okay. But important to see that, again, while not necessarily the most challenging, we're adding base numbers. If you can't access this because of vocabulary, you're in a lot of trouble. And again, there's no method for working, so sadly it's right or wrong. So we can push on now. Well, here's a few more that, again, we can perhaps look at. We perhaps won't spend the whole few minutes, but you're welcome to sort of pause here or work through these. And again, just how these key words can be really limiting. And so it's incredibly vital. Again, although we won't go through these now in the guise of time, it's well worth working through and just making sure you, or if not your child, can talk you through how you'd access these questions, because they will impact your ability to answer questions.
Thanks. So it's a good point actually about just ensuring that if you do want to go through these questions with your child at home, then you can. And I don't know, we've provided the answers actually within the booklet, but if there is any that you're not sure about yourself, then do come back to us. One of the things we did want to emphasize in the workshop today are some of the misconceptions, and Luke's actually highlighted a few things already about prime numbers and children not knowing, for example, that 0 and 1 are not prime numbers, and the first one is actually even, it's 2. And these are certainly things that we need to make sure that children have as a sort of a solid foundation of knowledge of. And there's a couple of things here about sort of misconception of forgetting, for example, that 1 is a squared number. And yeah, the idea behind these slides is to actually just go through some of the misconceptions around the questions that we just showed you. Did you want to just touch on the misconceptions, Luke?
Let's just whiz through them, and this will actually give you the answers. I think I can check my working. So there's 26, which is fantastic. There's 5. So here are my prime factors. They're the middle 2. 5 good so far. 2 for 2. And finally here.
Sorry, Luke, just on that previous one, quite a lot involved, isn't there, in that one? Yeah, knowing, for example, I might know what factors are, but what are prime factors? Also knowing what median means. I mean, you could reword this question and say, what is the middle of the prime factors of 21? The middle number, it would still work out. So, but yeah, a lot involved in that question.
And again, one tripping up point can then prevent you from accessing it, which is why this vocabulary is so vital. Again, what is it? You ensuring you can calculate those, having a decent method. And actually, I love this because 5 times 5 times 5, quite scary, but actually break up into steps. 5 times 5, 25, and that times 5, a little bit more manageable. And just making sure you have ways of accessing, and also sort of translate. What's it asking me to do? Oh, this isn't too bad. And I think for many of our students, if we just set them out with 5 times 5 times 5, they'd be okay, but suddenly the 5th cube number can be very off-putting. So here's some of the other ones. The sum of the first 5 prime numbers, incredibly easy to start on 0 and 1, miss 2, start on 3, and it's all gone wrong. So ensuring you know your prime numbers and knowing that you know what sum means. It's, again, multiple sort of opportunities to prevent students from accessing the question. So
and one of the things we do know, Luke, don't we, in terms of the answers that are presented in the 11 plus, they will often put an answer option in GL.
GL is
that could mean that you've actually made that mistake.
Yeah, well, they will do so intentionally. So they will add up. If you've thought 1 was a prime number, what will it be? If you thought 3 was the first prime number, what will it be? If you've times the numbers together, what will it be? So they will intentionally pick the answers that go with the misconceptions, try and lead you into a false sense of security, and it's something that we can't really prevent other than by making sure you have a really sturdy foundation. Work out the next number in a sequence, classic sequence, just having a method in terms of writing out, okay, hang on, I'm going to list the difference each time. What do I notice? And just recognizing the sequence, incredibly important. And then going on to be able to say, the next step in the sequence is the following. just vital skills, and part of this may well be actually being able to sort of put words to the sequence each time. Again, can be particularly challenging. In this case, it's that you're adding the last number. So just you've got 11, which then shows up here, 17 is up here, 28, and so on. So you're adding the last number each time. Again, quite difficult to spot if you haven't been shown that. I think, where did 11, 17, 28, 45 come from? It's actually able to spot, and only by writing out the entirety of that sequence, you actually able to see, I see what's going on. I noticed the pattern. The product of 6, 7, and 11. Again, what's product? How do we access it? Knowing that means multiply, and then having a method for multiplying the answers together. In this case, I love it. 6 times 7, 42. That's something within the remit of most students. But knowing how do we do times 11 for a number that really I'm not prepared for? Well, 10 times that number plus an additional 1 of that number gets us to 11. So being able to sort of separate up multiplications into easy steps, which again is hopefully slightly faster if you can handle, especially if you can handle this mentally, than doing a written method. To be able to tackle some of these questions and save time is really vital. And again, deciding to add rather than multiplying them to sort of save that time, really useful. Again, understanding the word range, knowing that it's the largest, and it's not just the numbers on either end. This is a common misconception. So here I got 34 and 51, so surely I do 51 take away 34. No, hang on, it's the largest and the smallest. If the answer is not in order, ensuring that actually I take the biggest and the smallest numbers. So many little traps that they can easily do. Selecting the wrong 2 numbers, again, very common misunderstanding. I think that's the end of these, and we move on to the angles topic and some sort of key hints and tips, which I'm happy to jump into. Chris, anything else to say?
Yeah, no, lovely. No, that would be great. Look, if you can start tackling angles. One of the things that we do just mention before we start going into this, of course, children are not allowed any mathematical equipment in the actual exams. So for example, things like protractors, set squares, rulers, anything mathematical that they might use in their classroom to help them, they wouldn't be able to have. And certainly when we start looking at angles, what they wouldn't be asked to do is measure an angle with a protractor. So I thought that was just worth mentioning. It is mentioned at the top of the page, but I'll let Luke go through some tips and hints around angle questions. It is pretty much, certain there will be angle questions within the test somewhere, whether that's interpreting some sort of diagram that they're given, a missing angle, for example, or wrapped up with words. It could well be related, of course, to another topic like compass points or something like that. So certainly angles is pretty much likely to be there. Can I just before Luke does plow into angles, can I just thank parents for putting questions in the chat? I've had some really sensible ones about kind of the format of the test, and someone has asked, do the questions start easily and then gradually get harder as they go along? One of the things we have noticed, certainly with GL tests, then certainly the first questions that are set tend to be around number, place value, calculations. And yes, as it moves through, then it tends to get into more word problems or data handling or more multi-step problems. That can't be said, though, for CEM, that CEM tends to be, questions seem to be of what I would sort of describe as equal weighting. It doesn't mean that they start nice and easily and sort of gently introduce concepts. They are sort of from the outset always seen to be quite challenging. I think that's mainly down to the fact that they have a short number of questions. They don't really have the scope, if you like, to start nice and easily, 5 or 6 easy questions and then harder later on. They all tend to be around the same level. I know it is sort of more commonplace, isn't it, in maths exams? And I certainly remember from my own GCSEs that the first couple of questions were generally easier than later on. And maybe that is more assigned to GL, but I don't see that with CEM. Would you agree with me on that?
I've certainly seen questions later in the exam that are more accessible, which is why skipping, moving on, not deciding, no, I'm going to stick here on question 13 and by God, I'm going to do it. And then all my time has gone. And actually, questions 20 through 25 were all 10 seconds, easy marks. I've certainly had that feedback from students. Oh, thank goodness I skipped it. I've still no idea how to do it. But I then went on to get 10 more questions. And certainly I would teach that no, better to go in with an open mind, and it's entirely possible the last 3 questions might be the easiest of the paper, because also it does depend on our students and what they've done most recently at school, versus something they did at the beginning of the year. And so I wouldn't expect there to be a guarantee in terms of it being any harder towards the end.
No,
And I would, even if we know it does increase slightly, I would prefer students go with an open mind, thinking, well, every question's a new chance to be able to access that maths.
Another question that we did have in the chat, which was really about if the topics are not covered at school, how are we sort of expected to go through that at home? It was a really good question. At the back of the booklet, there is an appendix, and there is a list of topic areas that appear within the 11 plus. So I'd certainly refer you to that if you want a sort of a fairly definitive list about the different topic areas that come up and you want to be going down through. I'd also say books like CGP that we often use have a very good contents page that will list out the topics for you. And it is a case of making sure you go through those. And if I refer you back to the list that we had earlier on number, that is also quite a good little tick list of making sure that you have focused on those at home if you want to. But I'd also like to think that you'll be able to trust in our course, trust in our revision program over the Easter and the summer months, to make sure that everything is covered off and your child has good exposure to all the areas of maths within the 11 plus. I can't certainly remember a time where a child has come out of an 11 plus test and said, oh, no, Teach It Right didn't cover that. It certainly has always been with maths that we have been able to cover off the topics that have appeared. I think certainly with things like non-verbal and verbal reasoning, there is more flexibility for them to change the style of question types that potentially no one else has seen. But maths has remained fairly standard through the years in terms of what they've set. Thanks, Luke.
So really, this is now sort of my area to blast through as many areas of maths, misconceptions, hints and tips as I can. Partly because we feel by informing you guys, you'll be able to then support your students, so your children more ably. And again, just try and highlight areas and misconceptions. So angles is not a bad place to start moving on from vocabulary, because it highlights, again, one of the features of maths is that occasionally there will just be rules that students are expected to know, where again, without access to these rules, they'll not be able to access the question. So in this case, great example, interior angles within shapes. It is expected that students will be able to know 3-sided, 4-sided, 5-sided, and really as at least higher 6-sided shapes, what the interior angles are, either by memory or to have a method for learning them. And so up on the screen is a nice hint. There is a formula for this, where if you have the number of sides of a shape, subtract 2, times it by 180, you get the answer. And this is something that will be often taught in schools and students will be expected to learn. I have a nice way of doing this visually that I actually prefer, because what I tend to find is students will almost always turn up at Teach It Right knowing that in a triangle, all the angles add up to 180. And that seems to be a fact that's fairly well learned, which is wonderful. It's the first of the facts. The reason I like this, and it's makes part of the hint, is because actually you can use this fact and a bit of understanding of where this formula comes from to work out potentially any sided shape. And so I'm going to give you an example here now on my rectangle. If I know that a triangle is made up of 180 degrees, all the internal angles, just to draw it out, it would be these 3 angles here. I take my 4-sided shape that perhaps I haven't memorized, I haven't learned, but I know to split it into 2 triangles going from corner to corner, vertex to vertex. Well, that's going to be 180 from this triangle, another 180 from this triangle, which means my total, in terms of I add up all the angles, is going to be 180 plus 180, which means I have 360, which again is a fact that students are more likely to have learned, but there'll be a smaller percentage who know, or most students will know 180, perhaps not everyone 360. And certainly as we go to larger and larger shapes, if I was asked a 7-sided shape or 8-sided shape, knowing that as long as you start in the same corner and split your shape into triangles, in this case I have 3 triangles, well, 3 lots of 180 is going to give me 540. And that's going to be the number of internal angles within a shape. Is incredibly useful. Similarly, I'm sure many of you can guess, how many triangles will I split now into my 6-sided shape? So I'll start in the same corner. Well, that gives me 1, 2, 3, 4 triangles. So if I now do 4 times 180, I'm going to get the number of, or the total number of degrees in a shape. this as a skill is particularly useful because it means rather than learning, potentially maybe as high as a 9-sided shape, each of these different facts and figures, you now have a method for working out potentially any shape in terms of the angles within, and that's particularly useful. So here we have sort of 720 degrees. So having methods like this where you're able to actually sort of circumvent or condense perhaps 6 or 7 facts into one is really useful, and also just ensuring the students understand that actually what we're doing now when we do n minus 2 times 180, which is a little bit abstract. Well, if we look here, the number of sides of my pentagon is 5, n minus 2 gives me 3, and oh my goodness, well, that's 3 times 180, that's what we would have had using the formula, I think is really useful. So actually linking where did this law, this random arbitrary rule come from to actually, oh, okay, hang on, it's just how many triangles can I put into my shape is really useful. So particularly useful question, not only now, because now if I can work out the interior angles within any sided shape, if I want to know what a specific angle is, so for example, the question asks me what this one angle here is, provided it's a regular shape, again, one of our definitions, regular meaning all the sides and all the angles are the same. If I take 540 and divide it by 5, well, I'll have 108, which is each of the angles. And so again, these sort of nested questions particularly useful, and this fact here, and just knowing that actually, yeah, if I split my shape into triangles and count them, because everyone knows the triangles are 180, students find that a lot easier to remember rather than these formulae, which can be quite challenging. So again, example here, a trapezium, a shape we could divide into 2, so 2 triangles, or 4 minus 2, so 2 times 180 gets us to 360. So particularly useful little fact there, sort of circumventing some of those nasty formulae that otherwise have to memorize. So angle word problems, some lovely examples. Again, I think it's worth just having a chance to just go through a few of these. And again, what I will probably do is I might give you a sort of a bit of a head start, have a look at a few of these, and then I think just whiz through certainly these 3 so that we can answer them. Again, just see sort of the varieties that can come up and the facts needed. Again, keep an eye on number 2 as well, sort of tying in ratios and angles. Dastardly questions. I'm going to get my timer. Just give it 1 minute's head start, and I'll just slowly work through. I think my advice for many of these is actually true for many questions is to sketch things out. So the examples before, I'd be sketching out the pentagon, sketching out a rectangle, and then dividing it into 2 to get that visual aids working. So I'll just start whizzing through and just again talking about these. So again, east to west, having some sort of mnemonic, some way of remembering. So again, never eat shredded wheat is very common, or naughty elephants squirt water. Ways of remembering actually how to label the points of the compass. And in this case, actually just having a drawing rapidly speeds things up, a short, sharp sketch. So now how many right angle turns are there in a turn from east to west? So in this case, east to west is going to be 2 right angle turns. It's 180 degrees divided by 2. Question number 2. In angles in a triangle or in the ratio of 2 to 1 to 1, what's the largest angle? Again, just do you know that all the angles of a triangle add up to 180? If not, no matter how strong your ratio skills are, you're scuppered. And in this case, being able to then divide 180 into the appropriate ratio. So the largest ratio here is going to be 2. I haven't done much ratio work yet, but just as a reminder, in order to divide things into a ratio, you take the total number of parts you're dividing into, in this case 4. So we're going to split 180 into the 4 parts. And that will give us the value of 1 part. So in this case, whatever method, short division is generally the way of doing it, but actually a particularly nice method for dividing by 4 is to half and half again. So 90 half to 45. So 45 is the value of 1 part. Well, my largest angle is going to constitute 2 parts. So it's going to be 2 times 90 degrees, which somewhat rather spoils it because I did, oh, sorry, not 2 times 90, 2 times 45, which gives us our 90 degrees. I suppose my drawing of a right angle triangle did somewhat give it away.
Interesting, Luke, actually, just again, based on sort of jottings and things and the speed we want children to work at, that certainly I'm just watching you do that question, there would be elements, wouldn't there, that potentially children could do very much mentally in their head, that
Absolutely.
once they'd established that 45 degrees was one part, doubling it to 90 should be something they should be able to do fairly quickly.
I think so.
And there are things that, you know, we often talk about with our students, things like doubling, knowing their times tables, having good knowledge of addition and subtraction. It is important they have that, because if they are, for example, someone that would find dividing 180 by 4 very challenging and it needs a lot of methods, then that is going to be difficult for them to do.
And it will just impact the time they have available. And so again, although I'm in the habit of drawing things out for purpose of explanation, Chris is absolutely right that really we want to do the minimum amount of working to get an answer correct. And the reason for that is, of course, we don't get marks for working, only for correct answers. And so certainly a piece of advice I will frequently give is the minimum working necessary, provided it's 100% correct. And that balance will be different to each student, sort of depending on their needs and their ability. But building that mental ability, building mental acuity, and encouraging students, especially the ones who are less confident, to say, no, go for it mentally and see what your answer is. And well, we'll work it out later if we need to, is really vital. Certainly in students who lack confidence in maths, I think that's something I would really...
It is that equilibrium though, isn't it, Luke, between doing something mentally and writing it down, that there is children trying to do things all in their head. There is a very large chance that they may well make a mistake. So yeah, writing things down that they want to retain or remember, and particularly when it's a multi-step problem, then wanting them to make those jottings is important. I'm just a little bit conscious of time, actually, Luke.
That's right.
We are at 5 o'clock and want to get through as many topics as we can. I wonder whether we could, well, just quickly go through perhaps some of the angle ones, but then move on.
We'll move on. No, I think we'll probably finish here. Again, question 3, just simple definition. Do you know your obtuse angles, your acute angles, your reflex angles? Are you aware of your definitions? Again, can you very easily run to a wall, best mathematician in the world? If you don't know what they are, you won't be able to access them. And then really just to finish that last point, it is about knowing your student, knowing your child. Are they a bit overconfident? Were they willing to just do no working for anything? Or are they a bit shy, not unsure? Will they do reams of working for something they already knew the answer to? That does sort of come down to knowing your child. Just a few rules to make sure you're aware of. And again, so here you have your obtuse, your straight, your reflex angle, your full angle, knowing between 90 and 100, between 180, 360, knowing your answers accordingly, making sure you've got those definitions down. And also just a few more angle facts that sort of tie in with knowing about shapes. Being aware that opposite angles are in fact equal, knowing that supplementary angles, so this is what we would call angles on a straight line, add to 180, much like the triangle, can be a really vital fact. Being able to sort of say, in this case, A plus B equals 180. Again, are facts we would expect students to know and be able to apply to various problem questions. So again, just a brief moment there, just have a look through, and being able to sort of use correct terminology is really useful, because many of the questions will be of a certain terminology. I think next we have algebra, which is sort of everyone's favorite topic. And I think of these, again, I will sort of just go through, highlight a few things. But before I do, I think the first of these sort of algebra questions, because they do sort of tie in together, is a bit of BODMAS. BODMAS, I think, tends to be in secondary schools. BIDMAS, as you get higher up. So this word other can also be indices. Essentially, it's terms like square numbers, square roots, generally sort of the powers would be all examples. And what I really want to highlight, although this here is the sort of the more standard BODMAS, I really don't like it, because it leads to a lot of confusion when you get into the addition and subtraction arena. So actually, I would strongly encourage you, your students know, or your children know, how to set out BODMAS in this manner, because divide and multiply, add and subtract have equal weighting. And what that means is, in the case of division and multiply, whichever order you complete the operation, it will be the same. And actually, often it's worth dividing first, because it makes the answer smaller. But if you multiply first and then divide, you'll end up at the same space. But the most vital of all, addition and subtraction, purely by convention, we do it from left to right. And so I think a question that I see an awful lot, for example, we've got, let's do 10, let's do -3, add 4. This is the one that will stump many people. if we are just following our addition first, then subtraction, this would become 10 minus 7, because we're adding the 3 and 4 together, which gets us to 3. So that's one possible answer. Or are we doing 10 minus 3, which is 7, then add 4, which is 11? So which of these answers is correct? And best advice for this is to sort of think in terms of change, where you're at the supermarket. If you had £10, you spent £3 and were given £4, I think if you suddenly had 7 at the end, you'd be quite cross. So in this case, this top one here is correct. And you have fallen, if you have gone for the lower option, into the fatal trap of essentially putting brackets in where brackets do not belong. So if you wanted to get this bottom answer, you would have to do the 3 and the 4 first, but that's what really our brackets are for. So please remember, in the instance where you have add and subtract, you simply work from left to right. And this causes a lot of consternation. Then why, why BIDMAS? Why is it add then subtract? Well, it isn't, and it shouldn't be. It should in fact be this. So BODMAS with divide and multiply, given equal weighting, add and subtract, particularly keen so that from left to right. And again, I do think talking about it in terms of money, in terms of change, can help certainly a lot of adults. Ensure you know where you're at. But please don't fall for that trap. So let me just get rid of that, just sort of make it very clear that the correct answer most certainly is 11. And again, putting it in terms of a sentence, I was given £10, I gave away 3, I was given 4 more. That can help you sort of ascertain where you're supposed to be at. And so again, here's an example, a perhaps more complicated example, where you have to apply BODMAS. So by all means, give this bottom question just a quick go. I'll give you maybe just 20 seconds in view of time, a bit of a head start, and I'll just work through it. One of the things I will say that's particularly useful with BIDMAS is to do it in steps. Don't feel like you have to attempt it in one go. 2 or 3 steps, I think, can be a really useful approach. So for me here, I'm going to sort of start simplifying. So 5 squared, that's self-contained. It's indices and other questions, so I can say that's 5. 25. In my brackets, self-contained, I can turn that into a 5. So what haven't I done? Well, I've not yet done this divide, so let's fill that back in. I've still got this minus 3. So that's step 1. And then what comes first? Well, in this case, divide comes first. So 25 divided by 5 is 5 minus 3. And then I sort out 2. And I can see well done in the chat. So if we're getting involved, well done. You beat me to the punch. But very important to be able to follow those steps and just, empower the students to be able to access these questions, because this certainly is a question that could easily work its way into an exam paper.
And it may well only be one or 2 questions that could appear in the test on BODMAS or calculation,
or even just be embedded as a part question, a necessary step to access a question. It may not be the focus, as in this case, it may just be a part of the question. So we have some algebra questions. I just want to run through a few of them, highlight a few of the things, a few of the methodologies really for tackling these questions. So in this case, question 1, you've got sort of an equation set up. My first advice is sort your numbers out and get those nice and simple as possible. So in this case, 5 times 6, well, those are numbers. I can sort that out. So immediately, I'm not going to waste any time. I'm just going to rewrite my question as 30 is equal to 300 divided by b. And already that becomes far more appetizing, because if 30 is equal to, 300 divided by 10. And many students right away, if they verbalize this, 300 divided by what? That's quite often a favorite, rather than using the algebraic letter. Well, 300 divided by 10 gives us 30, therefore b is 10. And again, this is one of those things where encouraging the students to make that leap as soon as they spotted the answer, rather than going through the formalized method, in this case of swapping them around, dividing both sides by b, and then it's actually far simpler just to recontextualize, ask that question. I'm sure many students will be able to make, or most students will be able to make that leap if phrased appropriately. Number 2, bit of nth term and sequences. So the 24th term is given by the nth term of a sequence. Well, what is nth term? How do we use it? And knowing that actually just the nth terms is almost like a little cheat code calculator, that if we take the number of the sequence we want and put it into our formula, so in this case, the n is 24, we rewrite this as 24 plus 2 times 24. So again, a bit of algebra, just knowing that 2n is 2 times n. I tend to write the times in there in my working. Now means I have constructed a question that a student can access, but knowing how to do that, knowing how to sort of substitute values in a question, especially in a question like this, it doesn't actually directly say substitute in your values. You have to know what the nth term is and how we use it. Can be quite challenging. And again, a bit of BIDMAS here sneaking in that we're able to access. And for number 3, very standard sort of question, having students be sort of familiar with the concept, written out fresh, that by moving across the equal sign, so for example, I've got 9 times something minus 7, but I want to get rid of that minus something, I can, in fact, take it to the other side of my brackets, and it becomes an addition, is really vital and really, really useful in terms of being able to access these questions. In terms of methodology there are many ways of sort of representing it by the drag and drop, or the fact that we are, more correctly perhaps, adding 7 to both sides is really useful. So in this case, 9x is equal to this, so 9x is going to be equal to 63. And again, perhaps it's at this stage I'm able to say, well, then 9 times what is equal to 63. Many students will say, 7 times table, therefore my x is 7. And really, again, how many steps, what working out do we need? Can your students get away with just this? Can your students get away perhaps with jumping straight to there, doing in your head the fact that 56 plus 7 gets you to 63, ensuring you access those answers more rapidly? And again, it's all getting a feel for that and sort of knowing the levels required. But that very standard, we would call that an equation rearrangement question, where you're rearranging the equation to get the answer, particularly useful. So substitution, bit of reverse bid maths there, knowing how to untangle to do in reverse order, really vital. Combining angles and algebra. So here we have a question, which is an X, a missing question. So how do we set this up as an answer? Well, we need to know a fact, first off, that right angle triangles are 90 degrees. All triangles are 180. So just being able to sort of set the question up, which is 180 minus my 90 minus my 12 is going to be equal to X. So constructing your own equation, then being able to sort of potentially solve that by simplifying my numbers, really vital. In this case, what is the value of X? Understanding how what we call a number machine works. So you start with a value, you add 65, that gives you X, in which case X is going to be 354, add 65. Again, having a suitable method, be it column, be it mentally, for you to work out those questions, really useful. And there's a few of the algebra questions, but again, it just shows how with algebra, you can tie in sort of many areas of questions. Right, percentages now. Percentages are useful. They come up quite a lot. Again, they can be part of many questions. Quite satisfying once students have mastered it, for them to be able to work out their own percentages at the end of a test. I think that's something that really demonstrates mastery. So first thing really to talk about with percentages, knowing what percentage means per century, per 100, be it century in terms of years or century in terms of cricket. Understanding it means out of 100. And so 70% is in fact the fraction 70 out of 100. Really, really useful and really important to be able to access these questions. We're going to go through just here. So to find 20% of a number, the method I tend to teach at this level is the same for all things, and it's to work out 10%. And that's because 10% is something of a magical number. 10% is the only percentage where the way you work out 10% is to just divide by 10. That is not the case for 20%. To find 20%, we don't divide by 20. Which for those more mathematically minded among you, the reason why is, looking back to what we said earlier, 10% is 10 out of 100. And 10 out of 100 is a fraction, which is 1/10. So to find it, we do 1/10. So my advice for working out any percentage is to always start with 10%, because it's the only one where 10%, you find it by dividing by 10. So that's sort of our first key message. 10% is dividing by 10. And from there, we do a couple of sort of to really get to our answer. Well, 20% of a number is 250. Well, I know then that 10% is going to be dividing by 10. So I can say that 10% of my number is going to be 250 divided by 10. That's quite quick. I could do that mentally, hopefully. 25. If 10% is 25, what then would 20% be? Well, hopefully you can see that is twice as much. So my answer is going to be 2 times larger. So 250. And to be honest, this is the kind of working out I'd expect to see in an exam. 10% is this, 20% is the following. For teaching, I might just write this on the side to sort of say I've times by 2. And really being able to
sorry, can I just interject very quickly, just because it sort of ties into what you're talking about. One of the parents has just asked, do the children need to show their workings? Back to something we sort of highlighted at the beginning, was that children are not rewarded, if you like, for writing things down. I think where we want children certainly to be astute and quick is on simple things when we're dealing with something like percentages, to be able to work out 10% of a number. You know, if you've got 10% of anything, as Luke said, you're just going to divide by 10. We wouldn't expect a child to necessarily write out the whole calculation they need to. They haven't got time to do that. And the reality is, any 11 plus test, if you wrote everything down that you're going to do, you'll run out of time. So there are certain things that we want children to be able to do, quickly in their head. When the numbers get slightly larger, or the calculations, or there are more than one calculation you have to do in a word problem, then potentially they may need to write it down. But the message we want to give our students is that you can't write it all. If you want to get to the answers quickly, then you need to do some of it mentally in your head. So thanks for asking that. I think, you know, one of the things we all get children very aware of, and certainly in block 5 and 6, when we start doing more on time management and working against the clock, this is when we start, getting children to be aware of how long they're taking. But to answer the question, really, then no, they can't write everything down.
And again, it is a balance with the students in terms of what they're strong at. But here, just to highlight, 15%, one of my favorites. You won't do through the whole process, but in this case, we would always start with 10%. Whatever 10% is, we worked out by dividing by 10. Again, hopefully mentally, maybe making a note of it so we don't lose track. How do I access 5%? Well, simply to halve it. So that if 10%, for example, was 50, well, my 5% then is 25 in this given example. And just having those skills, being able to then rapidly get the answers, really useful. I will just show you the last one, of course. How do we access 1%? Well, it's going to be 10 times smaller than whatever 10% was. So in this case, it would be 5. And then from 10%, 5%, and 1%, just in terms of adding, we can access any value. So I will just show, because it's quite a good example I like to show the kids. If I wanted to work out 17%, that would be a combination of 110, 15, and 2 1s. So 50 plus 25 plus 5 plus 5 gets us to that answer quite quickly. And this would be the kind of simple, quick, minimalistic working that I'd want to see if, again, necessary. And again, it very much depends on the ability of the students to sort of hold numbers in their head. And I certainly when I say it gets sort of a step of 3 questions, I would suggest, making notes to keep track, but then try and do as much as you can in your head.
And one of the things I think, just to emphasize again, Luke, about sort of people trying to do as much as you can at home and making those or gaining those opportunities to do maths. One of the things with something like percentages, it can be something very simple to do actually in the car. If you're taking your child to school by car or going on a trip somewhere, just asking them percentages of numbers. What's 10% of a number? What's 5%? What's 20%? What's 25%? And just very quick fire. And the more children practice those simple calculations, the easier they will be. And we'd love to think every time a child sees 25%, they know it's a quarter. And it just taking those opportunities to do percentages, I think, is really important. And I'm sure, even if you're out shopping and you spot a sale sign, just talk to the child about, well, how would we work out 10% or 5% or 1%? And the more you discuss that topic with your child, the more also they can relate it to real life. And I think that's really important, because if maths isn't tied into real life, and Luke's an absolute expert at doing this in his lessons, is actually drawing in, well, when would we use it? When would we use this particular topic area in a real life situation? So please do try and take those opportunities just to fire questions at your child. If they're in the car, and I've always said this, they can't run away then either. So you've got them.
Absolutely. And again, it also, especially for students who are more hesitant to do mental maths, out on the go can sort of force and encourage them to sort of say, oh well, I'm not going to write this down, I'm in the car, maybe I'll give it a go. The other method, just quickly to highlight in terms of how we would handle putting things into percentages, is quite nice working out scores. So I got 17 out of 20 on my maths test. Really, the method is give yourself a fraction and then put that fraction out of 100. And then sort of ask myself, how do I get there? Well, in this case, 20 times 5. So to keep my fractions equivalent, I do the same. And sort of this fraction-based conversion in terms of working out percentages, I think is the fastest method that we have. There's accessing it. In this case, 17 times 5 is 85, and I now know that is 85%. But again, minimum necessary working. If the student needs this, that's fine. But if they can do these steps mentally, all to the better. So just a few questions here just to whiz through. This is worth doing, I think, because it sort of highlights sort of some of the methods we've talked about. So if a jumper is £15 and it's reduced by 45, what this question is saying, work out 45% and then subtract it. So my method is going to be work out 10%. How? By dividing by 10. That's going to give me £1.50. From that, I can then quite easily work out 5%. That is 75p. I've made note of these. I can now compile those together and say, okay, then, well, probably easiest to go to 40%, which is going to be 4 lots of 10. So it's going to be £1.50, add 4. Again, in this case, hopefully you can just see, add them together. So it's going to be £6. And then 5 added on the top is going to be £6.75. And in this case, just make sure we read the question. Did they want 45, or in this case, does it now cost? So it's realizing, I have to take this away. So the student hopefully be able to access £15, subtract £6.75. And again, using whatever method is appropriate for them, be it column or whatever method they've learned. But being able to sort of break it into those little steps to be able to access the questions, I think is really useful. And just sort of saying, be able to turn what could potentially be a lot of jottings into hopefully not too much. Really useful. Number 2, I'd handle that in the exact same way. I would probably work out 50%, because I may well know that that is half, and then 10% twice. So these might be the percentages that I would work out. In this case, £55 and £11. And then combination of those, so 55 plus 11 plus 11 gets me to 70 rapidly. And again, having a chat with your students, well, do I need to do 10% 7 times? Or is there a faster way? Are there shortcuts I can take? And actually having these discussions, because there are sometimes slightly more optimal ways of working out the percentages, really useful. And again, number 3 here is an example of the one we looked at before, where you can't go, sadly, from 32 out of 40 straight to 100, much as we would love to. So there has to be sort of an intermediate step. Shows a good mastery of fractions. Well, in this case, on the way, if I can get to 20, you saw earlier, I know that 20 times 5 will get to 100. Can I get from 4 to 20? Yes, I can. So in this case, I'd be dividing both sides by 2. So in this case, 32 divided by 2, only 16, and then times 100, giving my percentage. So again, having these methods and knowing how to sort of set them out in sort of the minimalistic way as possible, access those questions is really, really useful. So in this case, 16 times 5 would get me to my answer. Any other questions I wanted to sort of look through? Again, increasing in price, just making sure I work out 15% and I add it on. Identifying that keyword, what do I do? What is 30%? For this, I'd work out 10%, times it by 3. He has 30%, so working out what 30% is. I think that's it really for percentages in terms of the key skills. So working out percentages of amounts, modifying by increasing or subtracting, or turning a fraction into percentages. They're sort of the key skills to make sure you've got a good mastery of for percentages. Which leads us nicely on to fractions. Anything to say, Mr. Pearce?
I don't think so. I think certainly thanks for going through those percentage things. I think interesting now we're going into fractions, but you've already heard us talk about fractions in connection with percentages. I think one of the key things that we always emphasize at Teach It Right is that with topic areas, they're very much interlinked with each other. And, a child who is generally good at percentages generally is quite good at fractions, and actually not seeing them in isolation, because maths is all about making those connections. And certainly, as I said earlier, if a child sees, 25%, if they are able to link it with a quarter, then great. And we want children to be like that. Certainly if think of a number like 63, for example, then do I know that that's 7 9s? So sometimes it's about looking at an answer and then making the links. So when numbers appear, and certainly with the 11 plus, numbers tend to be manageable. I'll never forget when a child came out of an exam, an 11 plus test a few years ago. They said, one of the questions was 217 divided by 7. And I was able to do it really quickly. And it just sort of proved the point that numbers are not there to catch children out in terms of decimals or remainders. They are what I would describe as manageable numbers. And I think that's something, again, to sort of reassure your child that the numbers they're going to be giving the students in the maths test will be numbers that they're able to manipulate and manage. But yes, it does tie in, Luke, doesn't it, fractions into other areas.
It leads on quite nicely because, of course, they are linked. FDP, fractions, decimal percentages, are also what we call a sort of key part of the curriculum, because they are in fact the same thing, just disguised. So again, keywords, numerator, denominator, just being able to refer to those is useful. It's well worth, if you can at home, rather than saying so we times the top numbers times the bottom numbers. Actually introducing that terminology and using it consistently really helps the students to learn what is going on with their fractions. I think we'll just jump straight to the questions, where I can sort of hopefully give some tips and insights. So in this case, Jenny has 108 cupcakes. She sells 72 of them. What fractions does she sell? Give your answer in the simplest form. Students need to know really that the simplest form, even if it's not asked for, is quite often the way to get there. So in this case, she sold 72 of them. So she sold 72 out of 108. And again, just sort of identifying, well, hang on, this looks familiar. Are these numbers both in the 8 times table? Possibly they are. And do I have a good method for being able to solve them? You may spot these in the 8 times table, fantastic. But if not, how are you going to be able to sort of access and, quite often I'll say, and students, especially with simplification, will quite often pause and spend quite a while looking for the largest number that they can work out goes into both numbers. And sometimes it can just be as simple as saying, well, hang on, both of these numbers are even, therefore I can halve them. So I'm going to end up with 36 and 54. And that then may sort of lead me on to sort of slightly easier numbers. Both of these in the 6 times table. So that'll give me to 6 and 9. And suddenly I'm sort of on the homeward stretch where it's much more manageable. And so I would just encourage students, especially when simplifying both ratios and fractions, don't be afraid to just do maths, give it a go, use the first number that comes to mind. Even if it's a couple more steps, it can often be a lot faster than sitting here going, right, I divide by 12 or divide by 18, and actually getting bogged down in analysis paralysis, not being able to find the largest common denominator between both numbers. Sometimes just getting started and halving your way down can work out quite nicely.
Luke, can I also just add on that? And it was just, again, just sort of in connection with what you were doing there, getting down to the lowest terms, is that generally with 11 plus maths, children will be expected to show their answer in the lowest form or simplify
always.
it down. And that is something we'd always encourage. There was, again, I'm not quite sure how true it was, but there was a question where the answers were equivalent fractions, but one of them was in the lowest terms. And I think, children would need to go for that rather than
I would always teach that you need to leave your answer in the simplest.
And it will sometimes say simplify, sometimes it won't. So again, it's sort of a golden rule. Yeah.
Dastardly.
Yeah.
So number 2, love this method, or love this sort of question. So a fraction of an amount. My advice is to set out the question. Of in maths is times. So this would be one way of doing it, but also just realizing that fractions of an amount be times by the top, divide by the bottom, times by the numerator, divide by the denominator. It's quite nice terminology because it's D and D. And again, in terms of this, how we access the question, well, really, it's your choice. You can multiply first or divide first. It's worth highlighting to the students, and actually 32 divided by 4 leaves us with 8, which is much easier to times by 3 than 3 times 32, which is a lot harder, and then having to divide whatever that answer is, 96 by 4. So choosing to divide first, if possible, is a far easier method. And this is kind of really the difference between, I think, being able to do it mentally. So 8 times 3 versus 96 divided by 4. One of those I would probably reach for a method, and one I would be able to do in my head. So just knowing we times by the top, divide by the bottom, times the numerator, divide by the, and this really is enough then to sort of say, okay, well, it's going to be 3 times 8. Which we can get to relatively easily, 24. And again, many of these steps may well be able to be done in your head, which is fantastic. Right, question 3 is a question that I see, I get a lot of questions and emails about because it's a particularly strange question. How many sixths are there in 5.5? What does that mean? How does that work? Well, the first thing to say is how many sixths are there in 1 whole? Well, that would be 1/6. So in a whole, you would have 6 sixths. So there's a few ways of doing this. You can just work out, well, then, okay, if there's 6 sixths in 1, I've got 5 of them. I'm going to have 5 times that amount, so 30. Or you can actually take the number of 5.5 and divide it by 6. That will actually get you to the same place. I think it sort of depends on how firm a grasp the students have on the term 6 and how you work out. I would probably actually say, there are 6 sixths in 1. I have 5 of them, so I'm going to have 5 times 6, so it's 30 sixths in 5. How many 6 are there in a half? Well, 1/2 is equivalent to how many 6? And this sort of way of just setting out makes it slightly easier. Well, from 2 to 6, that's 3, so they're going to be 3 6. So my answer is going to be 33 6. But just being able to set that question out or understand sort of what the question is, I think can be quite challenging. So how many fractions are there in a whole number? Questions are quite challenging, and sort of breaking it up into steps, dealing with the whole numbers, dealing with the fractions, is probably the method that I would choose. But certainly not easy, and quite possible to fall into a trap there. And again, also not leaving the answer as this, because of course, how many are there? There aren't 33 over 6. The answer is 33 of them. Just being able to sort of spot that in terms of so GL, they could very easily have 33 over 6 as an answer and 33. Well, which is it? Going back to the question, what's it asking and why? So yeah, keep an eye out for number 3, because again, I guess I got a lot of emails for that kind of question. How many halves are there in 7 ones? Again, another question. How many halves are there in 7 ones? It sounds confusing. Again, start with 1 whole. How many halves are there in 1 whole? Well, there are 2 of them. So in 7 ones, 7 wholes, there's going to be 7 times that amount. So 14. Just breaking up into the steps of going on can be quite challenging. So 3/5 of a donut. Again, this would be a classic. Times and divide. So 3/5 of 35. Again, let's divide first. It makes it smaller. So that's going to be 7 times by 3, 21. We can do that in our heads, hopefully, without too much difficulty. And 48 people in the newspaper, 3/8 of the men, the rest are women. How many women? That's a kind of classic question where they'll give you 3/8, but what they actually want you to work out is the other fraction. So do I know there are 5/8 are women? And actually going there first, saying, all right, well, it wants me to do 5/8, so let's do 5/8 of 48. And again, same method. Times by the top, divide by the bottom. I'm going to choose to divide first because it makes it simpler before making it more complicated. That can save me time and potentially lead to a question being able to be done mentally versus resorting to a method. Because again, if it was 5 times 48, I'm not going to want to do, but 5 times 8 I can handle much more comfortably.
It might seem quite simplistic, actually, Luke, what you did in terms of the underlining there, but actually that would be, again, something we would want children to do if it sort of reaffirms them exactly what they've got to do. So where Luke underlined women at the work, then that would be something, again, that you'd want children to be able to do just to reinforce that they've read the whole question. What we have seen over the years is children actually stop at certain points of the question and not actually read exactly what they're being asked. So the first thing with any word problem is to read the whole thing, understand what they're asking, and then go back and maybe go through those individual steps. So word problems, and these are easy enough to create at home as well, around things like fractions and percentages, would encourage you to do as much of that as you possibly can. We know that with something like fractions, it isn't just going to be a calculation they're going to present, it is going to be wrapped with key vocabulary.
And certainly there will be an answer of 18 in this question, which is the 3/8, which is the number of men. There are 18 men in this example, and that will be one of the GL misleading answers. That's the kind of thing they will certainly put in there. So just making sure you go back and read the question, right, what was it asking me for? I've done some maths. Let's just check if it was the right maths, or if there's a little bit more. It's sort of a vital step to make sure that you're doing. So again, decimals, part of the FTP sort of triad, really important to go through. Which of the following? So again, we'll just jump straight into the questions. How do we handle decimals? What are the methods? So in this case, what is this written as decimal? 6/24. So what does that mean? Well, first off, it's this. How can I manipulate this? How can I get this into a decimal? To be honest, for manipulating decimals, I tend to always go back to essentially the percentage. It's the same thing. I want to get it out of 100, because as soon as my value is out of 100, I can just take 74 out of 100 is 0.74. So I'm going to try and sort of manipulate this into something that can be easily multiplied up to get to 100. So in this case, let's see what I can do. So I can get 3 out of 12. Well, that's not too bad. 3 out of 12, I can say, is a quarter. And now maybe I just know, a quarter, that's 25%. That is 0.25. Or maybe I have to times it up to get out of 25 or out of 100. But being able to sort of go sort of simplify down slightly and then work my way back up can be really vital. And again, having these sort of key jumping off points. Oh, bingo, hang on, I spot it. I know what a quarter is. I've learned that. I've memorized what that is a percentage, and therefore the decimal really, really useful. So he lives exactly 1,000 meters away, 75% of the way. Again, tying in now percentages, but then giving my answer as a decimal. So how much further does he need to walk? So do I know quite rapidly 75% is 3/4? And if I know that, then I can easily work out there's a quarter that's left. And again, I now know how to do a quarter of an amount because I times by the top and divide by the bottom. So 1/4 of 1,000, well, it's actually just dividing by 4. Times by 1 doesn't change it. So I've got 250 meters. One of the things I'll just highlight here is now that they've introduced units. So although I've written my answer as nicely 250 meters, hang on, there is no 250. So I've got to do another step of process, sort of simplifying units or working out which units they've given. In this case, 0.25 of a kilometer is actually going to be equivalent to 250 meters, and making sure you have those transitions and able to work out where to go with my answer. Again, another sort of block that I'll put in the way, and a sort of a common trick and trap.
Equivalent values, Luke, is absolutely imperative, isn't it? And being able to work out equivalent things units, like really, milliliters, liters, grams, kilograms, in this instance, meters, kilometers is important. And conversion charts and things like that. We've got a couple of books that we use at Teach It Right, which have conversion charts in the back. And again, they're quite neatly presented in terms of children revising those key equivalent values. But again, it can be something very easy just to test children on before they go into their exam and just say, can you remember how many milliliters in a liter? How many grams in a kilogram? And those kind of things will certainly stand them in really good stead when they come to the test. And as Luke mentioned, the question may well deal in one unit, but actually the answer is about converting into another. We tend to find, don't we, Luke, that it tends to use metric rather than imperial, really, doesn't it?
It's very much gone that way. Yes.
Yeah.
And I certainly wouldn't expect students to know the conversions by heart, which
no. And again,
may have been a consideration, but
yeah,
if they do, they will give the conversions.
They will, exactly. And I was gonna mention that certainly if there is any conversions like that, they tend to provide that for the students. So again, it's a bit of peace of mind that if they were asking the sort of, I don't know, miles to kilometers, for example, they would generally give them that to work with.
Like 5/8, they would give you that, and it's more of a fraction question.
Yes, that's right. Yeah.
One thing to note, number 3 seems quite sort of deceptively simple, but just making sure we've covered operations, but how confident are your students or your children of applying operations to decimals? It can be really off-putting, and just making sure that you've nicely aligned thanks to place value, and are not going to get put off by the fact that my decimals have to be in the same place and I can just apply the same methods. It's something that's worth checking and ensuring that really, decimals hopefully shouldn't phase our students. They are handled in the same way through the column addition, column subtraction, column multiplication. But are they secure? Are they able to apply those methods? That kind of question, potentially, if a student hadn't seen it before, and they might freeze when actually really it's the same method they've been learning sort of all the way through. Again, a range of questions, and I think one of the things that we don't have a picture on, but I know certainly in class we cover, learning the sort of the division rules. So, for example, knowing how to work out if a number divided by 3 is will work or not. And so, for example, let's do 761. Is this divisible by 3? Question mark. Knowing that if you add the numbers together, so 7 plus 6 plus 1, if that total gives a number that is divisible by 3, then yes, it is divisible. Is what we call, I'll type this out, the divisibility rules are well worth looking up. And actually, there's a whole chart, and obviously some, the divisibility rules for even numbers, you can divide them by 2. It's very easy, but some of these can sort of offer some shortcuts for what can be otherwise some very challenging question types, and just making sure students, know these or are aware of these. And certainly for the sort of 3s and 7s, which tend to catch students out, are quite useful. So in this case, 7 plus 6 plus 1 gives us a total of 14, which is not divisible by 3. Can't do it by 3. Therefore, this is not a number that is divisible by 3. And in fact, let's just check 761 divided by 3. No, it gives us some horrible recurring 0.6. Is really useful, and certainly for the more sort of questions that, again, otherwise, how would you know that? Well, actually, it's these divisibility rules that they're expecting your students to know that can really catch students out. 75 out of 100. Well, that means this fraction. But again, if this many people do visit the beak, what percentage don't visit the beak? So if we have 0.75 that do, that means 0.25 that don't. Again, these reversals, or these sort of almost double negative tricks, really common and potentially liable to cost you a mark if you're not on the eye out for it. Again, so underlining do's, don'ts, what are they asking for? Number 6, Steve has pumpkins. Again, how much they all weigh together. So just being able to just add, and again, ensure that you've lined up your values properly, could throw students for a loop if they've not come across it before. Certainly, as well, I've seen questions in a similar manner where this value will actually be 450 grams. So now we're at kilograms and grams, and then being able to say, oh, hang on, let's get them all into kilograms first, then add them up. Again, they sort of can sort of throw students and slow them down. Wiz, Mr. Pierce, is quite a good one. I'll let you.
Yes, you are probably aware, but within a lot of our teacher lessons, then we do like to use different games and activities that support whatever we're teaching. And one of the very popular 11 plus games is something called Whiz Match. Now, we've certainly suggested it to you, I know, in the verbal reasoning workshop for synonyms and antonyms, but they also do a version which is for equivalent values and about matching up things like percentages, fractions, decimals, and it can be really, I think, very good fun, but also very valuable for children to learn about equivalent values, pairing them up. It is sort of turned into a bit of a game, so you could potentially do it with your child, and it sort of gives them that instant feedback about whether they're correct or not. It is available on Amazon, but we certainly do use it in our revision camps over the Easter and the summer, so it is a game I'm sure your child will be exposed to at some point, and we do use it in the lessons as well. But we like to recommend things like this that certainly have a direct impact on their knowledge for the maths section.
Right, I'm just going to quickly whiz through. Brief look at averages, something we do cover in quite a lot of detail, but really it's just definitional. Do we know the mode, the median, the mean? Do we know the pitfalls that are associated with them? So mode is most common, median is middle, again, mode and modal, and then mean, you need to add and divide for the mean. In particular, it's possible for there to be no mode. It's even possible, technically, for there to be bimodal, to have two modes. Knowing that is a potential option. There is no mode. The answer isn't available. The median, they need to be in either ascending or descending order. You can't just choose the middle height person if you're all shuffled randomly. You've got to get into height order, and then you can work out who the middle height is or what the middle value is. And then to solve for the mean, it's the mean one, because it often involves the most maths, the most steps. You have to add them all up and then divide by the total numbers. There are loads of little rhymes out there. Hey diddle diddle, the median's the middle, you add and divide for the mean, the mode is the one that appears the most, and the range is the difference between. Lovely, there's loads of these, some great ones out there that you can go through on YouTube, play and sort of sing and get stuck into your head.
I was going to say, I was hoping you were going to sing that, Luke.
Well, I wouldn't inflict that on all of you. I do with the students, I must admit, much to mine and their chagrin. But no, they're fantastic. And actually, I will say as students, I have my year A-level students singing things like this, because once they're in forever, they don't go away. And really, these little ways of remembering it are so useful. I'll go through a few, again, questions just to highlight some things that are particularly important. So what was the mean number of goals? In this case, we add the zeros. Zeros count when using means and medians. Even though a zero value, this means we have 1, 2, 3, 4, 5, 6, 7, 8. So our total number is going to be divided by 8. So we'll add up the following and divide by 8. But just realizing that even though 0 is not a number in this case, but it is a result, and you divide it by the total number of results. So in this case, for our one of these values added up together, so our total, but divided by 8. That's a mistake I've seen an awfully large number of times. Catch students out. They'll be divided by 6 because they think the zeros aren't real. Oh, love this. Right, number 2. reverse engineering the mean can cause people no end of difficulty until you realize one sort of fundamental truth. If his mean score was 7, then we can work out the total. Because, and just quickly write out sort of the formula, so the mean is the number, so we call that the total, divided by the number, I often say, the number of values. Well, if they've given us the mean, and we know there are 1, 2, 3, 4, 5, 6 values, we can always get to the total by timesing the mean by the number of values. And this step here, for whenever it's not just a simple work out the mean question, the first step is always work out the total. And that takes these questions to be incredibly challenging and sort of nail pulling. Oh, so I can't do it, I don't know what's going on. To actually hang on, before you do anything, work out the total by timesing the number and the mean together. And that will then get you to a far, far, far more manageable question. So in this case, if I know that the total is 7 times 6, I can work that out. It's 42. And now I can take away all my values to get my missing ones. In this case, it's going to be 42, subtract the 10, 32, subtract the, probably the 4 and the 6 for another 10, until I get down to my remaining number. And again, just very quickly there's some little tips. I would be taking away, that's 10, then probably 7, then 5. So 42, take away 10 twice, gets me to 22. Take away 7, gets me to 15. Take away another 5, leaves me with 10. So that's a few mental tips in terms of pairing numbers to make them easier to add and subtract. Pairings of 10, particularly useful. Track all my values, I'm going to leave the total of 10, which means I know that last value had to be 10. So for any of these sort of mean manipulation questions, please remember, always work out the total first, and then it becomes far more manageable. Because otherwise those are particularly pernicious questions that can students have no idea where to start, whereas work out the total from the mean and you're good to go. The median, again, you can only work out the median if it's in the middle, if it's in height order. It's possible to go through, in this case, 1, 2, 3, 4, 5, 6 answers. What's the middle going to be? Even if I rewrite these in order, so 14, 23, 28, 7, 28, I can actually stop there because I've identified that, hang on, my middle is somewhere in here. Well, there is no middle number. So what do I do? And having the students realize that if you have an even number of answers, you're always going to have 2 things in the middle. And the correct answer is actually to find out the middle of those 2 numbers. So in this case, I will write it out for completeness this time. So 32, 35. My middle number is actually going to be 27.5 because it's between the 2. And so the method I mentioned earlier of adding the 2 numbers and dividing them by 2, if you can't spot that it's halfway, this luckily works out quite nicely. But again, I've seen questions where, my middle numbers are 17 and 21. What's the middle there? Useful to be able to rely on a method, just add and divide by 2, and knowing how to handle that. So that's a particularly trick question. You've got to reorder it, find the middle of the 2 numbers to give yourself the median. Really useful. Again, what's the mean rainfall? Again, this involves now adding decimals. So tying into, do we have a method that's suitable for that? And then dividing our total, in this case by 4, which will be dividing a decimal. Do we have methods? Range the following numbers. Again, perhaps the most common thing I see is they'll just take the first and last numbers rather than the largest number and the smallest number. That tends to be, other than just not knowing what the range is, that's the most common mistake I'll see. So it'll be 78 minus 17 for that question. Really, that's all I wanted to say for those, the big trips of reordering, knowing that there can be no mode, and knowing if you have to manipulate the mean anyway, find the total. That'll stand you in good stead. Data handling questions, there's sort of a wide range of stats, and we can look at a few of those there. Chris, anything to say on the last topic?
No, Luke, thanks for going through all those things on averages, and it is something again we will focus on in block 4 with our year 5 pupils. Data handling, we don't have a huge amount of time left, and data handling is very, very big in terms of topic. You've got things like pie charts, bar charts, Venn diagrams, Carroll diagrams. I'm afraid the list does go on and on. So I think what we will ensure is that children do get an opportunity to interpret graphs and charts, be able to work out how to read different ways of presenting data. Even things like frequency charts and pictograms can be used as well. we do have certainly the books that we use do have to cover off data handling in a lot of detail, which is great. But I don't know if you just want to focus just on a couple of things, Luke, particularly things like pie charts, because I know that is something that children do find a little bit more difficult. But once they're able to associate it with degrees and link it back to percentages, we've obviously already talked
percentages
about.
and fractions. Yeah. I think that's exactly it. And just really sort of being able to sort of create their own sums from the pie chart is really the important thing. So in this case, how many children prefer red? Classic example. Well, we need to know that 30% of the students, which is a fraction, 30 out of 100. So we can now say, well, out of our total, then it's going to be the same fractions. It's going to be the same amount out of 600. And being able to sort of construct your question is really the crux of it, because then it does tie back into either your percentage or your fraction skills. Being able to just say, right, okay, 30% is 30 out of 100. So this fraction will be the same as the fraction of the total, is really what all the pie chart interpretation skills come down to. And then just realizing, of course, that, well, if I've worked out 30% are whatever the case in this may be, so it's going to be 0.3 times 600. If I then want to work out 10%, I can go the same trick as before. 30% is going to be dividing by 3, so you can actually start to make the same links. But I think really just constructing that first step is sort of vital to being able to unlock most of the pie chart questions.
Can I just echo that, Luke, again, about, well, certainly about the first question, because certainly CEM are quite inclined to give children a question at the beginning that they need to work the answer out to, but then they will use that information later on down in the questions. So this one here, if they were to get that wrong and not work out that it was 180 and put something else, they would then use that information later and then get that question wrong. So really important from a sort of a focusing point of view that children get that first question right, because it may well be that it informs them later on into what they're doing.
That's right. And then just also to give them that confidence to say, right, well, I know that's 180. I can now know my tricks. If I know that 30% is that, 10% is divided by 3, using those same skills before, sort of prevent them from having to rework things out from scratch every time. So actually better use that answer rather than going back to the beginning. Really important. Total number of preferred blue and pink adding them together. So again, really from here, most of the questions are just manipulating that. And so what the training then becomes is doing that in the most efficient way possible without resorting back to the beginning every time. And I think that's just something sort of to highlight. Again, this is interpreting graphs, being able to read again, because they don't have equipment. It's just maybe perhaps using things like pencils, just to be able to sort of draw these lines and read off, sort of, the lawyers have pencils with them, so holding up vertically, reading across, things like that they won't be able to do because they aren't equipped with a vast array of sort of tools of the trade, and just ensuring that they don't sort of fall for the traps. Again, total they could easily use. What is the sum of all the days' range? Adding in those words, the range, again, keywords. Being able to just realize that this is in fact relates to a day, so that is Monday, Tuesday, things like that. Being able to read graphs mostly comes with experience. There's not too many different things, otherwise interpreting that kind of data. Just have a sort of flick through if there's anything else we've got here. No, not really. And again, it's many of the same pitfalls and traps as before, but just in new contexts. And if we can tick off and say, yep, I've seen that, I know what the traps are, it's going to be part of our course and what we will do.
Thanks, Luke. I know we very much this evening sort of touched on the main topic areas. There are ones that we haven't really talked about, things like volume or probability, but these are areas that we would cover within our Teach It Right course. There is an appendix at the back of your booklet, and it does list down the main topic areas covered in an 11+ exam, and would certainly ensure that you do have a good look at that. Also within the appendix, there are some suggestions of some games and activities that you may well want to look at to support your child at home, and that's things like apps. There are some really good 11+ maths apps out there, certainly for times tables, but there's also ones where children can actually do actual tests on an iPad or on a phone. I think certainly just varying that maths practice, and children using various websites, IX L is a very, very good one for word problems. It just can vary that practice. I think children always working on paper and pencil methods, sometimes it can get a little bit monotonous. And I think if you can vary that practice with your child, we would certainly suggest that. We have also got a series of masterclasses that you're probably aware of on a Monday evening. Ati Pillai has started those. They started on the 10th of January. Unfortunately, at the moment, they are full. We have sold those lessons have actually sold out. So we had to ask Ati if she wanted to do an extra lesson from 6 to 7. She very kindly said she'd be more than happy to do that. If you would like to get onto those courses, onto those classes on a Monday evening, please do let the office know, because we are very happy to open that up for an extra hour or have another lesson between 6 and 7. And really just to make sure there's no disappointment around if you weren't able to sign up for those classes. Ati started with glorious geometry last week, and the kids were fantastic. They really were, and lots of questions firing around, but having a really good go at some areas that, potentially they hadn't done with us before. But to give you the peace of mind that, of course, all these areas that are mentioned here on the screen will be covered in block 4. But if you just want your child just to be slightly further ahead and just get a bit of a head start, then you may well want to sign up to those. So if you could let us know via email, if you would like your child to be part of those lessons, we can certainly open those up for more students. Just on the slide above, Luke, could you just click on that one? That's the one regarding the app First Past the Post, which again is very, very good for the 11 plus, covers all the different objectives. And there's another one which I really have found incredibly useful called I Am Learning To, which is another really, really good app to use. As I say, most of these games and activities we've got on the slides today are mentioned in the booklet. We play a game called Trilemma, which is great fun, actually more so with our year 4s, actually. Just to introduce things like factors, multiples. Basically, it's like Connect 4, but children really do enjoy playing this game. And as you can see, the questions around sort of square roots, prime numbers, and kids choose which color they want to go to. And it's a really good fun game. It is more suitable for lower key stage 2, I would say. But if you do feel that your child's times table knowledge needs a little bit of a boost, this is certainly a lovely family game that you may well want to invest in. You can buy it on Amazon, just type in Trilemma and it will pop up. Thank you again.
One thing, Chris, we haven't said as much, times tables.
Yeah.
Some students incredibly solid, some students not so much. And if that is the case, you'll get far smaller return on investment than doing anything other than times tables, again, in the car on the way home. Because as we say, if you've got 30 seconds and you're trying to work out ratio and also trying to work out where it is on my graph, and it's also a pie chart, and hang on, what was a triangle, and you're struggling to 7 times 8, and that's taking 20 seconds of your time, you've now got 10 seconds to handle the rest, you are really going to struggle. So if timetables are not a strength, absolutely please do invest time into making them so, because you will save so much time and heartache and label them to really struggle with the very challenging questions and processing, and really you are putting them on, well, they are on the back, but if they don't have that strong basis. So if it wouldn't be a math talk if I didn't say it at least once, but if timetables aren't a strength, please do invest time into making them so, because it is the most valuable thing you can be doing as a first basis.
Thanks, Luke. And I think certainly in our year 4 course, if your child is in year 4 with us, then that certainly in this current block has been very much a focus, learning their times tables, making sure they're secure, which will help them once they get into year 5. As Luke said, though, if your child is in year 5 and their times tables are not as strong as they could be, then it is about practicing. Sometimes I'm always sort of struck by how sometimes within school, they sort of stop at 12 times 12 and don't go any higher. It is certainly worth learning things like 13 times table, 14 times table, and making sure those are secure, because that is the level that the 11 plus will go to.
Thanks, 15 Luke. Times 15 is a...
Yeah, absolutely. Yeah, certainly worth going a bit higher than 12 times 12. Could you just stop the share, Luke, for the moment? And first of all, thank you very much for coming along this afternoon, and I hope you found it useful. Thank you to those people who have put questions in the chat. Is there anything else anyone would like to ask about maths, or anything you would like a little bit more clarity on? Please don't hesitate to unmute and have a chat with us. Just ready for your tea, I expect. Well, thank you, Luke, very much for joining us this afternoon. If your child is fortunate enough to be taught by Luke, or even over the summer has an opportunity, I think he's a wonderful maths teacher, and I know certainly gets the best out of children in terms of their maths ability. And I'd like to say all my tutors are very, very good mathematicians, which certainly is quite infectious. Actually, it certainly rubs off on the children, and getting to the answers quickly, which we know is important. Thank you very much for coming along, and I hope you found it useful. We have recorded this session in actual fact. I'm afraid I didn't record it right from the outset, but certainly only about 10 minutes in. So we will send over a link to you during the week if you happen to want to rewatch it. But thank you very much, everyone, for joining us this afternoon, and I hope you enjoy the rest of your evening. Thanks a lot. Bye. Thanks for coming. Thank you.
Thanks, guys.
Thank you. Thanks very much. Thank you. Thanks very much.